Hello everyone, today we are going to discuss about the shortest job first algorithm. It is an algorithm that you select the waiting process for execution with smallest execution time. Basically, this algorithm is divided into two parts. One it is preemptive and another it is non-preemptive. But today we are going to discuss about preemptive. For example, here we have our example. There are four processes: process 1, 2, 3, and 4. Each process have arrive time and burst time. So at the first time, we're supposed to determine that which process it is the first coming. So we can look that process P1 it is the first come at time 0. Process P1 is already coming. So process P1 at time 0 is coming. It can execute until at the time 2. At the time 2. Why at the time 2? Because at this time process P2 is arrived. So here we can determine process P1 and process P2 according to our algorithm that the smallest execution time is you select the smallest execution time. So we can determine that at this time process P1 it is burst time it is 7. So after execute at the burst time 2 it remain 5. So we can determine that process P1 and P2 which is the next process to execute. So we can look that according to our algorithm, process P2 it have burst time 4 and P1 it is a burst time 5. So process P2 it can execute next. So here P2 also it can execute until the 2 time. That because at time 2, 3 and at time 4 process P3 is coming. So P2 also executed at the time 2 time. So here can be 4. So process P3 after already arrive also can determine here, but process P2 the burst time is remain 2. So here also can determine we can determine between process P3, P2 and P1 which is the next process to execute here. So according to our algorithm, process P3 it have 1, P2 it have 2 burst time, and P1 it have 5 burst time. So process P3 it is smallest execution time, so can be next to execute process P3 here, and it is burst time it is only 1, so you can execute at 3 to 5. So at this time 5 and arrive time we can look that P4 at the time 5 P4 is already also coming. So here process P3 it is complete, it is execution. So we can remain with process P1 which have burst time 5, P2 which have burst time 2, and P4 which have burst time 4. So according to our algorithm, P2 can be executed next because it is smallest execution time than P1 and P4. So P2 can be next, and it is burst time it is 2, so it will be 7 here. Also you can look that P4 can be next, so here can be 11, and the rest it is P1 can be next, P1, and it is arrived burst time it is 5, so can be 16 here. So we complete the execution between 4 process. So we can find the other activities like their complete time, their turnaround time, and waiting time. The complete time for each process, we can look at process P1, the complete time it is 16, so we can write here 16. Process P2, the complete time it is 4, we can write here 4. No, sorry, it is 7, so we can write here 7. And the process P3, the complete time it is P3, it is 5, so we can write here 5. And the process P4, the last time it is the complete time it is P4, it is 11, so we can write here 11. Then we come to find the turnaround time. Turnaround time is equal to complete time minus arrive time. This is the formula of time around time. So complete time for P1 is 16 minus arrive time for P1 is 0. So it can be 16, here can be 5, here can be 1, and here can be 6. Also, we can find the waiting time for each process. The waiting time, the formula can be turnaround time minus burst time for each process. So we can find the waiting time for each process. For process P1, it is turnaround time is 16 minus arrive time minus burst time, which is 7, so it can be 9. And for P2 can be 1, and for P3 can be 0, and for P4 can be 2. We complete the waiting time for each process. So here also you can find the average waiting time for all process. It is equal to total waiting time, which is 9 plus 1 plus 0 plus 2 over total process, which is 4. That is equal to 12 over 4, which is equal to 3. Thank you for watching. Please don't forget to subscribe. Thank you.